AP Physics 1. Today we will be talking about kinematics, motion in a straight line.
So we know that the d equals 15 meters, the initial velocity equals 20 miles per hour, and the final velocity equals 0 miles per hour. In physics, we use the metric system, so we have to convert miles per hour to meters per second. And we do this by using dimensional analysis. First, we're going to start out with using 20 miles per 1 hour. So then we're going to multiply it, put 1 hour on top, 3,600 seconds. Then we're going to multiply that by 1,600 meters over 1 mile to get meters per second, which is 8.89 meters per 1 second. The units cancel out, so the miles cancel and the hours cancel, so that we get seconds and meters left. And our answer can also be written as 8.89 meters per second. And since before we stated that the final velocity is 0 miles per hour, and since it's 0, the 0 will just be written as meters per second.
So we start with one of our 3 kinematics equations. We would either use d equals VIT plus 1/2 AT squared, VF equals VI plus AT, or VF squared equals VI squared plus 2AD. So our given first is our value for d. We also know our initial velocity and our final velocity. And we're trying to solve for our acceleration. So if we have d, vi, and vf, we're going to use our third kinematics equation. So first we have to start by rearranging the equation so that a is all by itself on the side of the equal sign. So if you subtract vi squared from both sides, you get 2ad equals vf squared minus vi squared. Then you divide by 2 times d on both sides, and you get acceleration equals vf squared minus vi squared over 2d. Now we know that our vf is 0, so vf squared is also going to be 0. We can just cross it out. So we have acceleration equals negative vi squared over 2d. Now from here we can just plug in our numbers. 8.89 meters per second divided by 2 times 15 meters. And that gives us an acceleration of negative 2.63 meters per second squared. Even though we don't need time to solve for acceleration in this problem, we did solve for it just out of curiosity, and we use our kinematics equation Vf equals Vi plus At, which can be rearranged algebraically to T equals Vf minus Vi over A. When we plugged in our values, we got negative 8.89 meters per second over negative 2.63 meters per second squared, which gave us a value for time of 3.38 seconds. However, when we did our actual demonstration and timed it using our stopwatch, we got time equals 4.2 seconds. There was a small error because in a real demonstration, it's hard to account for an exactly constant acceleration.
A common misconception that people have is that since the car is slowing down, that there is a decreasing acceleration. However, the acceleration is constant, but negative.
This is our position versus time graph, talking about the position relative to the end mark. So we start at 15 meters from the end mark and end 0 meters from the end mark, or at the end mark. In this instance, the position refers to displacement versus time. So the common misconception is the confusion between displacement and distance. Distance is only a scalar quantity, so it takes into account only magnitude and not direction, where displacement takes into account both magnitude and direction. However, in this instance, our distance and displacement are the same because we are traveling in a straight line and we do not change direction.
So we know that our initial velocity was 8.89 meters per second. And we slowed down to a final velocity of 0. And we know that this is constant. We know that this is a straight line because it was a constant acceleration. So a common misconception would be that the line would dip into the negative part of the graph, but this is not true because that would mean that the car would have moved backwards, which we didn't do. And this is because velocity is a vector which takes into account magnitude and direction.
Now our problem can be explained with a real-life demonstration.
We measured 15 meters on the tape measure, and we have stopwatch to time it.
Let's go!
Thanks for watching.